Hello students, welcome again. Today I am going to our derivative chapter 5 in the differentiability. It means derivative. Yes students, this derivative related our chapter 5, also the 6, and after that understanding whole derivative is also useful in the integration in the part 4. Yes students, our limit for related continuity and differentiability over. And then after I move ahead to derivative related numericals. So first of all I go to basic formula related our 11th science, trigonometric related and non-trigonometric related all derivative formulas. So I hope students you know our first formula f dash x is equal to limit x tends to 0 f of x plus h minus fx. That's our first basic definitions already you studied last year. Now derivative related numericals formula ddx of x raised to n. Yes, I think you know nx raised to n minus 1 second. Then after third ddx of every x raised to 1. How much? Yes, it is only 1 because x derivative respect to x, it is a 1 only. Now, fourth property, ddx of log x, basic, yes, it is 1 by x. Continue, fifth one, ddx of a raised to x derivative, it is a raised to x into log a basic. Students, difference between second and fifth, one of the changes, base is variable, power it is constant. Here base is constant and power it is a variable. So these are the two different parts. Continue sixth one. ddx of root x. Derivative is a 1 by root x. Yes, these are the six property related power. Next 7. ddx of root x. After that 1 by x minus 1 by x. Students, first of all I show you to all formula. After that I start our chapters. Next, 8th one. Now trigonometry related. Sin x, derivative, yes, it is cos x only. ddx of cos x. Definitely you know that it is how much? Minus sin x. Next, 10th one. ddx of tan x, it is sin square x. Continue, ddx of cot x minus cos x square x. Yes, this all formula already known students. It is a 11th science formula. Now 12th, sin, cos, tan, cot. Next, it is sec x. Sec x into tan x. 13. ddx of cosec x. It is also known, I think, minus cosec x into cot x. So students, you by heart these six formula in the pairwise, and this 1 to 7 by heart combined. Then after I go into our formula to inverse trigonometric parts. So first of all, I give you all listing for the formula. Next, continue. 14. ddx of sine inverse x. Up to that, I think derivative known. In this part, 14 to next, I derive. Don't worry. But first of all, I write down all formulas. 1 by under root 1 minus x square. 15. ddx of cos inverse x. Same as just only minus. Continue. ddx of tan inverse x. Yes. 1 upon 1 plus x square. Similarly 17. ddx of cot inverse x. Students, here you by heart pairing wise. These two pair are easily. These two pair are easily because same answer. Sorry, this one. Same answer, only small change. And last two is also pairing wise. 18 and 19. by heart for this to get it. Yes, ddx of sec inverse x. It is 1 upon modulus x in under root x square minus 1. And last, ddx of cosec inverse x is also same, just symbol change under root x square minus 1. So students, these are the 6 formula. It is new for you in your 12th science. Don't worry, this all derivative I explain you after the next part. But today I go into for formula level, and after that our short numericals. Formula continue. The working rules. Yes students, there are 4 working rules. First, ddx of any u plus v. So first derivative plus second derivative. Sometimes you have minus given, so you directly write down your minus. It is plus or minus property. I only show you the first one. After that, ddx of u into v. I hope you know both of the product rule. Yes. First, second derivative plus second, first derivative. This property already you know. But here I just write down one extra. ddx of sometimes u into v into w given. It means three functions given, maybe 4 function also. But if you 3 function given, then students will write down first derivative du by dx v into w same plus u dv by dx w same, and last u into v same but dw by dx our last function derivative. So if you sometimes 3 function given different all, then you follow this rule, that also called product rule. And students continue. One more you know, I think, ddx of u by v. Yes, u by v. It is a division rule. In division rule, denominator square v square. Now denominator, numerator derivative minus numerator, denominator derivative. Compulsory where v never 0. Then we can apply. These are the properties: denominator square, denominator numerator derivative minus numerator denominator derivative. These are the 4 properties. 2 is here and other 2 here are our working rule. Now I go to chain rule. Yes students, this is also parts of our working rules. Continue. Chain rule. Chain rule is also very easy. First of all, one of the function I just written dy by dx. It means derivative of y respect to x is called dy by dx. Again, derivative of y respect to x, it is called dy by dx. I show in the chain rule wise. Maybe this chain rule contain 2 theta, so d theta by dx, and here first dy by d theta. Look at that, d theta and d theta. If you cancel, surely you get out only dy by dx. But here respect to theta, I make the derivative. Same as if I write down again dy by dx. In this one more function joining d theta by du and du by dx. This is also true. But here 2 function joining d theta du du. Don't worry, I explain you in the numerical wise and extra numerical wise. Students, first of all I show the formula, after that show the numerical. So it's very easy. Don't worry. Chain rule and product rule are always not same. Our product rule is different, chain rule is different. Okay, next one more, same dy by dx. I go to one more functions. Look at that, dy by d theta by du, but here du by, just I change dw by dx. Look at that, here 4 function I am using, theta, u and w with x. So it is chain rule maybe continue the theta, du, dw, again also test dv. So, if you functions are given composite function, then we utilize chain rule. I explain you what is a composite function, don't worry. It is a composite function. Then utilize you chain rule. I give you one little example related product rule and related composite functions. Okay, so I just started the composite and product rule. So students, I just take you one little example. Given function cos x into root x, just I given two functions. Both are the separate product. So here I consider u and here I consider v. Definitely it is not a composite function. So I never utilize chain rule. I utilize product rule. After that I explain same question but only function change. Then it is a chain rule. So here derivative differentiation with respect to x, surely ddx of fx, and here ddx of my question cos x into root x. So it is m as x, and here apply students product rule. So first, second derivative plus second, first derivative. These are our two simple product rule. So cos x. Now just remind again, what is the derivative of root x? Yes, 1 by 2 root x. And derivative of cos x is how much? Yes, it is minus sin x. Nothing that this numerical is over. Here apply our product rule. Now same question. If you given students in this form, function fx cos of root x. Look at that. What is the difference between in this question and in this question? Here chain rule given because cos and root x both are the combined given. Here both are the separate given. So if you separate given both function, then apply product rule. But if you combine given, then students apply the chain rule. Now I go to chain rule method. It's very easy. Look at that. Here you consider cos theta and only reading cos theta. So differentiation with respect to x, same d by dx of fx, d by dx of my question. Now here it is x. Students, here reading cos and this consider your theta. In this way, only two functions are there. So cos derivative is what? Minus sin and ddx of root x derivative pending. Students, this root x derivative I mentioned here. Here not apply product rule. Yes, product rule is different, chain rule is different. Again repeat, cos theta derivative written minus sin. Theta is as it is and root x derivative pending by chain rule. Now students, root x derivative. How much? Root x derivative 1 by 2 root x. You never root x is a cancellation. Huh? Both is a separate. This is your final answer. And this answer students, both are the different. Yes, don't worry. I just one more example I explain you related our chain rule. So extra question continue. Same question I show you students. This one just a little change. Cos of root same. Here just I showing 5x square plus 3x. It means there are three functions I give. Cos, root and internal. Same apply. Differentiation with respect to x. So d by dx of fx. And here d by dx of cos same, and that is. It means dash x. Students, now here one more time I just highlight for you this function. You just consider it is your theta. So just read about cos derivative. How much cos derivative? Minus sine. Internal function same, and d by dx of this derivative pending. Actually, this part is showing by chain rule. So that does x. The same as under root 5x square plus 3x. And now read about, students, root derivative. What is root? This consider x internal full. What is root derivative? 1 by 2 root x is same 5x square plus 3x, and d by dx of internal function is same 5x square plus 3x. Don't worry, I just highlight this internal function is considered x, and that I declare. Now that derivative by chain rule, so at dash x minus sine under root 5x square plus 3x, this same 1 by 2 under root 5x square plus 3x, and here's the derivative for x raised to n. It is 10x plus 3. Yes, just I rearrange the all terms. So at dash x, my answer will be minus of 10x plus 3 upon 2 under 5x square plus 3x, and this function is as it is sine of under root 5x square plus 3x. Students, here our this question is ending. Okay, if you this question given not in compositions, maybe in this form given cos x and 5x square plus 3x, students, then apply our product rule by this. But if you joining function given, then apply our chain rule. But that kind of given, then you apply u and v, then product rule. So I hope you clear when apply product rule and when apply chain rule. If you separate function given, then product rule. And if you joining function given, it is composite function given, then apply chain rule. Yes, it's very simple and easy. Now students, I go to textbook illustrations. Now students, I slowly going to our textbook example. Up to illustration 20 already students I explained. Today I going to derivative related our textbook example 21 and 20. Before starting this sum, students, maybe this question given, maybe here, not given here, but if you just think out in your mind, sin x separate and x square separate, definitely u and v you utilize. And which rule apply? Yes, product rule. If you this given then, but here not given, so I not apply product rule. I apply chain rule. So these are chain rule differentiation with respect to x. This part only you think out in your mind, because sometimes that may given, then apply product rule, and not given, both are the joining function given, then apply chain rule. So differentiation with respect to x, dx of fx. Now students, it's very easy and very simple. So it is at x. Here students, just I consider this value is a theta. So what is sine derivative? Cos, and ddx of x square pending by chain rule. Yes, chain rule applying. Now at this x, cos x square same, and x raised to 2 for the x raised to n level, 2x raised to 2 minus 1. So finally done, cos of x square into 2x, and that's the answer. If you rearrange, my answer is 2x into cos of x square, and here done our final answer. for this numerical. But if you students in the way these two are separation given, then you apply product rule. So that kind of answer different, huh? And here answer different. Yes, same as example 22. Before starting 22, I again you show if you given 10x and 2x plus 3, surely you go to U and V product. But here not given, so you not apply our product rule. Here no apply product rule because my question given what? Composite function. It means both function are joining function given. That's why I start here differentiation with respect to what? X. Already in your textbook given derivative respect to x, that's why I written x, students. So ddx of fx and here ddx of chain 2x plus 3. Students, this is not writing in the solution, huh? This is only for understanding. This is only for understanding. Yes, f dash x. Now here, students, just think about this over theta. So, reading that, what is tan derivative? Yes, tan derivative is a sec square theta. And ddx of 2x plus 3, same as this function here applied. And mention that by chain rule. Yes. Now, see that the f dash x. Here sec square of 2x plus 3 is as it is. And students, what the 2x plus 3 derivative? 2x is 1 and 3 is 0 because constant. So your final answer 2 into sec square 2x plus 3, and here ending ours. Yes, students. For more practice, you try at home. Here sin x square written, cos x square, tan x square, cot, sec and cosec x square. Here also you try another 5 question, tan related, cot, sin, sec, cosec. Each of 2x plus 3 same and we write different answers. So I hope students you understood when apply product rule and then apply chain rule. Separate function given, then product rule. Joining function given, it is composite function given. Then apply what? Yes, chain rule. Yes, students. Now continue, students. Example 23. Here three functions are mixing given: sine, cos, and x square. So I go into our chain rule. Differentiation with respect to x. So d dx of fx. Here d dx of our question: sine with cos with x square. Yes, students. Now I just move ahead to f dash x, and here consider these two are one of the theta. So only and only you should start with the sine derivative. Yes, what is sine derivative? Cos, and our internal function is same this. And derivative for remaining parts, cos of x square by, yes, by chain rule. So f dash x minus cos, sorry, not minus, cos with cos x square. Here cos derivative now, and here also you combine, calculate, these are one of the function x square, these are theta. So what is cos derivative? Minus sine theta, and d dx of internal x square is as it is. This expression does I mention. So f dash x cos with cos x square, this same as minus sine with x square. And what is x square derivative? Yes, 2x raised to 1. I mean 2x raised to 2 minus 1. Finally done. Just rearrange your answer. Minus separate outside, 2x separate outside. So minus 2x into smallest to highest function I mentioned, cos with cos x square. Yes, students, here I have done this example number 23. Now I go to exercise 5.2. First question. Derivative asking respect to x and question given in y form. Students, y and fx is same as a. So here start differentiation with respect to x. So dy by dx of y, it is dy by dx, and here dy by dx of sine of same as. Students, here not given separate function, so I go to chain rule. Dy by dx same, and here just you follow these steps. This x square plus 5 is considered one of the theta. So tell me, what is the sine derivative? Yes, cos of theta into ddx of internal x square plus 5 as it is this argument by chain rule. It's very easy process. Finally, dy by dx same, cos of x square plus 5 same, and this internal function. Now I go to derivative. What is x square derivative? 2x raised to 1. 5 derivative is 0 because constant. So finally dy by dx 2x first. Smallest to highest function, right, students? Cos of x square plus 5. And that's done. Happily this answer. For more practice, students, you write down here different 5 questions. Cos x square plus 5, tan x square plus 5, cos x, sec and cot. Same as here also you write down sin cos written different derivative functions. And try to more practice our chain rule. Yes, students, chain rule is very easy process and simple. Continue, students, slowly. I go into question number 2nd and 3rd. Here also composite function given, sin and cos, differentiation with respect to x. So dy by dx, and here ddx of cos with sin. Students, one more time keep in mind, these are the theta, consider you, and first of all just say cos derivative. How much cos derivative? Minus sin. Theta is same, and ddx of what is the remaining? Yes, remaining sin by chain rule. It's very easy process. So dy by dx minus sin with sin x. Students, say sin derivative. No need. Yes, cos x. So just rearrange minus with cos x into sin with sin x, and that much our simple and easy answer. Now third one. Here also chain rule given, ax plus b with sin. So differentiation with respect to x. So dy by dx, same applying, d by dx of sin with ax plus b. So dy by dx. Students, here just you focus on that ax plus b is a separate function. So you consider theta, and first of all think out to sin derivative. Yes, it is cos theta. And which function is same for remaining derivative? Ax plus b. This ax plus b I show here by chain rule. So finally we done here. Dy by dx cos ax plus b same into. Now students, I go to derivative respect to x. So ax derivative 1, but b derivative what? 0 because constant. So dy by dx a into cos ax plus b, and here our happy solution over. Students, for more practice you try here cos, tan, sec, cosec, cot in ax plus b. Here also you try for more practice internal function change and going to your formula by chain rule. Now continue, students. I go to most most IMP numerical question 4 and pick problem most IMP for 3 months. Don't worry students, one by one I explain you. First of all, here look, sec of tan of root x, 3 function given. So 3 are decompositions. So differentiation with respect to x. Yes, it is dy by dx. And here d dx of sec with tan with root x. Only you just focus on that sec derivative, and here consider it is your one of the joining function just like theta. So what is the sec derivative? Yes, sec into tan. These are derivative of sec function. And which derivative pending? It is tan into root x is pending. These are pending function here actually. And theta is same as it is mentioned. Finally, dy by dx. Students here mentioned by chain rule. Yes, chain rule wise I doing that. Now here same as sec of tan of root x into tan of root x into, now students here one more steps, this consider is a theta. So tan theta, what is tan derivative? Yes, sec square theta, and d dx of, yes, root x is same. Because root x is one more functions after that joining. So tan derivative, root x is pending. Now I go to root x derivative by showing chain rule. So dy by dx, the same is right. Similarly, that also same is right. Into that also same is sec square of root x and root x derivative. Yes, it is 1 by 2 root x. Now finally, over here, just rearrange your term higher. Last right, lowest to highest right. So 1 by 2 root x into sec square of root x into, these are the function, sec of tan of root x into tan of root x. Yes students, here are one question for solution 4 done, and it is your 3 marks questions. I hope you understood properly. One more time repeat. These functions are considered theta, sec derivative, sec into tan, theta equals sec, and these are the same. Now tan is considered theta, so tan derivative sec square, root x separate, and root x derivative 1 by 2 root x, and these are same as. So this answer for your 3 marks done here students. Now I go into question number 5. This also I have a question for 3 marks. Students here sin ax plus b upon cos cx plus b. So I go to first of all division rule. Yes, differentiation with respect to x. So dy by dx. Here apply d by dx of your question, sin with ax plus b upon cos with cx plus b. Students, only I operate here what? Division rule. Yes. So dy by dx same, and here apply to our division rule. U by v rule in denominator square for denominator. Now denominator into d dx of numerator minus numerator d dx of denominator, that I will known for our division rule, u by v property. So dy by dx, students, it's very easy. Cos of cx plus d into, now what is sin derivative? Yes, it is cos ax plus b into, now chain rule because sin derivative over and ax plus b derivative pending. Now I show you here. Sin same into. Now this cos derivative. After that cx plus d derivative. Cos derivative minus sin cx plus d into c. X is 1 but d is 0 upon. Yes, upon this is cos square of cx plus d. Then our division rule. And one little chain rule, students, over here. Now I move ahead further. So finally, I just rearrange the terms according to my given values. Here, first of all, a write down dy by dx a into cos cx plus d into cos ax plus d. Then after look at that, this minus and this minus, plus c is as it is. So plus c into sin ax plus b into sin cx plus d and upon cos square cx plus d as it is. Now students, I just both of the division for subtract. One of this was divided and secondly these are divided. So you get it just only and only dy by dx. How much? A cos cx plus d into cos ax plus b upon cos square cx plus d. First I just divided plus similarly here also cos square I just divided into second terms cx plus d, and that same as c into sin ax plus d into sin cx plus d. Yes, students, this the cancel cos cx plus d one time, but one time pending. And here cos square cx plus d one time utilize here and one time separate right now. These are the one of the joining functions. So dy by dx a into cos ax plus b upon cos cx plus d pending. So further steps, students, I just this follow. After that second I explain. So here a into cos ax plus b into, can I write 1 upon cos? It is a sec of function. This answer given in your textbook plus now this statement c into sin ax plus b. Students, here one of the two time was given. So first I utilize with sin cos cx plus d and one more cos cx plus d are separated because I have two cos. Now I am sure this is the thing and that is the sec. So finally done here. C into sin x plus b into tan cx plus d into sec of cx plus d. Students, here our this numerical done and this here numerical for 3 marks. Happily done, students. And finally over this our this one. Yes, students, I hope you understood our one of the derivative formula, chain rule and product rule for basic and simple introductions. Yes, students, further explanation I explain you in the next video, next part. But you try to write down all formula minimum 5 times daily. Write down and then after you study start from this chapter. Daily you write down minimum 5 times. Then it is profitable in next also our 6th chapter and in this 5th chapter and also integrations. Yes, students, we are ending our parts. Thank you very much. Bye bye.